Unit 3, Lesson 3, Electrons and Chemical Bonding. Bound to change. Atoms join together in different ways to form millions of substances. We have limited number of elements. How the large number of substances are formed? They are formed by joining atoms together, and the substances may contain fewer number of atoms, such as water molecule, which consists of 1 oxygen and 2 hydrogen atoms. Other substances consist of a large number of atoms, as DNA molecule. Here, as you can see, each sphere represents an atom, so it consists of a large number of atoms. How do atoms join together? Atoms join together by chemical bonds. What's a chemical bond? A chemical bond is an interaction that holds atoms or ions together. When two atoms interact with each other and join together, this is called chemical bond. So the chemical bond is an interaction that holds atoms or ions together. When two or more atoms join together, they form molecule. So a molecule is a group of atoms that are held together by chemical bonds, like the water molecules and DNA molecule. In a chemical change, you studied before that the chemical change the identity of a substance. How come? Does this mean that the atoms disappears? Here we have an example. The green color of the leaves, it change in form. The green pigment color disappears. What happens? Chemical change, it changes the identity of a substance. So the green pigment, it changes to another substance which is colorless. So chemical change changes the identity of a substance. The green pigment here is a chemical substance. It changes into another substance with no color. It's colorless. It doesn't mean that the green pigment disappeared at all. The atoms disappeared. No. So chemical changes do not create or destroy atoms. Chemical change just rearrange the atoms. Atoms are rearranged to make new substances with different properties. Here, the molecules of the green pigment give its green color, while when it changes to another substance, it has no color. In order for atoms to be rearranged, chemical bonds have to be broken or formed. How come? As you can see in the figure, two hydrogen atoms, this is a hydrogen molecule, consists of two hydrogen atoms held together with a chemical bond. There is a chemical bond here between two hydrogen atoms. This is a chlorine molecule, consists of two atoms. These two atoms are linked together, joined together with a chemical bond. When hydrogen molecule reacts with chlorine molecule, first step is the bonds here are broken. The bond between the two hydrogen atoms is broken, and the bond between the two chlorine atoms here also broken. So this is the first step to break the bonds. The second step, after breaking the bonds, each hydrogen atom form a new bond with each chlorine atom. Here is a new bond is formed, and also here a new bond is formed. So this is hydrogen chloride molecule, and this is hydrogen chloride molecule. So hydrogen molecule reacts with chlorine molecule to form hydrogen chloride. Clear? Different models of the atom. We can't see the atoms, so we draw some models to show the atoms. What are the different? The first model to represent the atom is the electron cloud model. As you can see, the electron cloud model, here is the nucleus, and here the electron cloud, which represents the space in which the electrons can exist. This is the electron cloud model of hydrogen atom, as it has only one proton and one electron in this space. So the electron cloud model shows electrons are found in a region around the nucleus. This region, the electron may exist in any place in this region. This model helps to show the general location of the different parts of the atom. Here is the nucleus, and the electron can exist in this region. It does not show the number of electrons. The number of electrons are not shown here. So this is the electron cloud model, just cloud to show where the electrons can exist. Here is an electron cloud model for lithium atom. Lithium atom has 3 protons, 4 neutrons, and 3 electrons in this space, exist in this space, as we mentioned that the number of electrons are not shown here. The second model to represent the atom is the Bohr model. It shows the number of electrons in an atom, and this is different from the electron cloud model. This is the Bohr model for hydrogen atom. Hydrogen atom, the nucleus contains 1 proton, and here an electron. This ring represents the energy level in which the electron can exist. So each ring represents an energy level. This is an energy level, and the hydrogen atom has only one energy level, and only 1 electron is represented or shown as dot on each ring. Here, this is an electron. This model helps predict how and why atoms form chemical bonds, as we will mention after. The Bohr model in Bohr model, each energy level can hold a specific number of electrons. For example, the first energy level can hold up to 2 electrons. The first energy level can has 1 or 2 electrons, up to 2 electrons. The second energy level can hold up to 8 electrons. Can take 1, 2, 3, so on, till the maximum number of electrons that can hold is 8 electrons. And the third and the fourth can hold different number of electrons. the outermost energy level. What is the outermost energy level? Suppose we have 3 electrons. 2 electrons will be in the first energy and 1 electron in the second energy. So the second energy now is the outermost energy level. It's the energy level farthest from the nucleus that contains electrons. And the number of electrons found in the outermost energy level of an atom are called valence electrons. So valence electrons exist in the outermost energy level. Here an example, how are electrons distributed in Bohr model of oxygen atom. Oxygen atom has atomic number of 8. So how can we distribute the electrons? The first energy level will take 2 electrons, and the second will take 1, 2, 3, 4, 5, 6. The total number equals 8, which is the number of electrons or the atomic number. So the number of energy levels now equals 2. The outermost energy level is the energy number 2, or the second energy level. This is the outermost energy level. And how many valence electrons? The outermost energy level contains 6 electrons. So the number of valence electrons here is 6. 1, 2, 3, 4, 5, 6. The third model to represent the atoms or a molecule is the space filling model. In this model, like the shown here, and this is another model for another molecule, each atom represented with a sphere, and it shows the 3D arrangement of atoms, 3-dimension arrangement of atoms, how the atoms are arranged, and also shows how the atoms are connected or join each other. Which atom joins which atom? And here, as you can see, this atom joins this atom, and this atom joins with this one, and so on. So it shows how the atoms are connected to each other. Atoms are represented as solid spheres. This is an atom, this is an atom, this is an atom, and so on. It does not show the parts that make up the atoms. You can see the nucleus, the electrons, and so on. So it does not show the parts that make up the atoms. How does the periodic table show the number of valence electrons? Can we know the number of valence electrons when looking at the periodic table? Yes. We know that each column is called a group, and each group contains the same number of valence electrons. Here, lithium, for example, has 1 valence electron. Sodium also has 1 valence electron. Potassium has 1 valence electron. In group number 2, beryllium has 2 valence electrons. Magnesium has 2 valence electrons. In group 13, boron has 3. Aluminum has 3. In group 14, silicon, for example, has 4. Germanium has 4 valence electrons. Phosphorus has 5. Sulfur has 6. Selenium has 6, and so on. 17. Here, 17, it has 7 valence electrons. Chlorine has 7 valence electrons. Bromine has 7 valence electrons. And here in group 18, except helium, which has 2 only, which has only one level. Neon has 8. Argon has 8. Krypton has 8, and so on. So in group 1 and group 2, the number of group represents the number of electrons in the outermost energy level, or the number of valence electrons. In group 13, group 14, 15, 16, 17, 18, take the first number here, the unit number. Here 3 electrons. This group has 4 electrons, 4 valence electrons, 5 valence electrons, 6 valence electrons, 7 valence electrons, and 8 valence electrons except helium. Clear? So elements in the same group or vertical column have the same number of valence electrons. You can use a group number to find the number of valence electrons in group 1, 2, and 13 to 18. While the groups from 3 to 12, there is no simple rule to find the number of valence electron, and you will study in higher grades. Here, group 1, it has 1 valence electron in the first energy level in period number 1. Period number 2 has 2 energy levels and 1 valence electron in the second energy level. Period number 3, it has 3 energy levels and 1 valence electron in the third energy level. Group 14, it has 4 valence electrons here, and so on. Group 17, it has 7. Group 18, it has, except helium, which has 2 only, 1, 2, 3, 4, 5, 6, 7, 8, and so on. Example, determine the number of valence electrons in atoms of carbon, nitrogen, and fluorine. Where is carbon? Carbon in group number, this is group number 13, group number 14. So carbon has 4 valence electrons. Nitrogen in group 15, it has 5 valence electrons. Fluorine in group 17, it has 7 valence electrons.